Find the derivative of y equals the secant of 4t plus 5 over 3t minus 2. So y here is the trig function of an entire expression, which itself is a quotient, 4t plus 5 over 3t minus 2, which hints at how to take the derivative. Since we have the trig function as the outermost function, we're going to start with the derivative of that. But since its inside is a quotient, we will be making use of the quotient rule when we take the derivative of the inside, which is done when you take the chain rule. So our derivative, y prime, which can also be called dy dt, is equal to, we start with the derivative of secant. The derivative of secant is secant tangent. So we have secant, we leave the inside alone. We have tangent, again, you leave the inside alone. And now you multiply by the derivative of the inside of the original trig function. So the derivative of this inside here, which is a quotient, and will therefore follow the quotient rule. So we'll start with the derivative of the numerator, the derivative of 4t plus 5, which will be a 4. You multiply by the denominator left alone, so 3t minus 2, minus the numerator left alone, 4t plus 5, times the derivative of the denominator, which is a 3, and all of this over the denominator, 3t minus 2, quantity squared. And this entire thing is multiplying the secant and the tangent. So y prime, or dy dt, will equal, we'll leave these trig functions alone. So I would just rewrite exactly as I see it for each of them. There's no simplifying or anything like that that we can do with these. But we can simplify this quotient rule result for the derivative of the inside. What we can do is distribute the 4 into here. That will be 12t minus 8. And we can distribute the negative 3 into here. That will be a negative 12t, and then minus 15. All of this will be over the denominator 3t minus 2 squared, which we won't do anything with. Now in the numerator there are like terms that can combine. We have a positive 12t and a negative 12t. Those actually cancel. And we have a negative 8 and a negative 15, and those can combine. So I have the secant of 4t plus 5 over 3t minus a2 times the tangent of the same thing, 4t plus 5 over 3t minus 2. And this is going to be multiplied with a negative 8, negative 15, negative 23 over 3t minus 2 quantity squared. That's about as simple as we can make it. Now let's write it in the way that will most likely be found. And what that'll be is, generally the constants and the power functions are written before the trig functions, so that would mean taking this quantity that's in square brackets and just putting it to the front. So y prime, or dy dt, can be written as a negative 23 over 3t minus 2 squared times the secant of 4t plus 5 over 3t minus 2 times the tangent of 4t plus 5 over 3t minus 2. There's the likely way it'll be written. Now, one other option that we actually have here, these are multiplying each other. And the secant and the tangent, those are technically in the numerator because they're not in a denominator and they're multiplying. They'll multiply with the numerator. So it is possible to write those in the numerator. So here's an optional way to write this result. Y prime or dy dt will be, and all we do is put the secant and the tangent with that negative 23 in the numerator of the overall fraction. Other than that, we leave the secant and tangent alone. So I'll just rewrite them exactly as we see them. And then this entire thing is over 3t minus 2 quantity squared. Those are the two different ways you may see that derivative written. They are equivalent, of course, so just be aware of the two different forms it can take. But there we have the derivative y prime or dy dt.